Number 18. Calculate the pH and the pOH of each of the following species at 25 degrees Celsius for which the substances ionize completely. And then they give us letter C. So in this case, we have 3 molarity HNO3. Oh boy, do not get this on your skin. But we'll see why in a little bit. Now, first thing is that they give you a little hint that this substance is going to ionize completely. Now, there are only 3 substances that do ionize completely. Ionize completely just means that it's going to break down. Strong acids break down 100%, aka completely. Strong bases and salts. So this compound, nitric acid, should be ringing bells. And nitric acid is one of your 6 strong acids. We should memorize these because your teacher or professor might not give them to you. So all of these compounds will ionize or break down completely, 100%. Okay, so now we know we're dealing with strong acid territory. The next thing I'm going to show is via an equation, a balanced equation, how this breaks down. Well, we have HNO3, right? The acidic H in the front is showing that it's an acid. And when we split this up, right? When we break this down, it's going to go break down 100% into its 2 ions. But what are the 2 ions? Well, we know that the split is right here because NO3 is a polyatomic and H is going to be the hydronium ion. So we have H plus NO3 minus. Now, they did tell us that we're starting off with 3.0 molarity of HNO3. When we see that, we have to figure out how much is it going to be in terms of H plus and how much is it going to be in the nitrate ion. Well, this is where we pay attention to the coefficients, the big numbers in the front of our balanced equation. But if you notice, they're all 1s. For every 1 HNO3, I have 1 H plus and 1 NO3 minus. So if these numbers are all the same, what do you think these numbers are going to be? Yeah, they're going to be all the same, right? A 1-to-1 means that whatever number you started with, that's how much you end with for this ion. So I have 3.0 molarity in terms of hydronium, H+, and I also have 3.0 molarity for the nitrate ion. But remember, we're solving for pH, and we need to solve for pOH. Now, with everything that I collectively figured out, I gotta somehow find out what I want. Well, I want to either find the pH or the pOH. And these are the 3 equations that deal with pH and pOH. Which one am I going to use first? Well, since we're dealing with acid land, there's only reds up here, this can't be going on, right? We're not in base territory, so I can't find the pOH first. We're over here. We can find the pH. Do we have an H plus concentration? Yes, we do. And this is the only number that I care about. I don't care about this anymore, and I don't care about this. I only look at that H plus concentration. So I can find out what that pH is. pH is the negative log of the H plus concentration, which we now know is 3.0. So let's see how acidic we are on the pH scale. Remember, really low values are acidic. And if I do negative log of 3, oh my goodness, I get a negative value. That's why we don't want this stuff on our skin. It will burn right through. So we get a negative 0 point, and if we're doing sig figs, just know that pH values are a little bit weird. The total number of sig figs that you see here are the total number of sig figs after the decimal. So I need 2 sig figs after the decimal. So it would just be 4.8. No units for pH. And that's our pH value. Now we're going to find out the pOH. So I just found the pH. So let's see, how am I going to find a pOH from a pH value? This formula. And I'm going to star this up because you're only allowed to use this formula under one circumstance, is that if you're at room temp, which is 25 degrees Celsius. But they did tell us that, so we are allowed to use this formula. Now if I just say pH plus pOH equals 14, we just found out that pH value, we're looking for the pOH. So if I just quickly rearrange this formula, it would be pOH equals 14 minus the pH. You could plug it in directly if you wanted to. I'm just going to save a little bit of writing space for me. So the pOH equals 14 minus negative 0.48. So we're going way above on the pOH scale, and that also is an indication of being way acidic. So this is actually going to be 14.48. Once again, no units on the pOH scale, and we have figured it out. So there you go, guys. Those are your two answers, pH and pOH done. Hopefully this helps. Let me know in the comments. Subscribe to the channel. I really love helping you guys, and I hope you guys are getting great educational content. Just leave a note in the description. What is it called? The comments. And that just lets me know that I'm doing my job right. Thank you, guys. I'll see you all in later lessons. Bye-bye.